Good afternoon. Thank you for coming. My name is Anssi. I'm Director of Analytics and Service Assurance Business Unit at Expo. Today I wanted to talk to you about predictive mobile transport assurance. I'm not sure if you're familiar with the topic, but I'll start by explaining a little bit on the background. So let me try to put it in the context first, that why is this a relevant topic to be discussed here today. So we did a survey. We asked service providers, we asked the operators that what do they think that what is one of the main concerns when they are moving into 5G and new network infrastructure. And actually the results were quite surprising. So about 1/3 of them thought that the biggest bottleneck in moving into 5G is going to be in the backhaul network. Now, the surprising part here is that the backhaul is not actually going to change much when moving into 5G. And that's exactly is the problem. So in 5G you have new technologies. You have C-RAN, you have fiber to the antenna, you have the cell densification, which is supposed to multiply the capacity of the radio network. And you have in 5G we are introducing new generation core network, which is multiplying the capacity of the core network. But actually there aren't many changes happening in the backhaul network. So it will remain as it is, whereas the speed on the radio network part is going to be 10 times that it was in 4G, right? So obviously this is going to create another bottleneck, especially on the backhaul part of the network. So there are a couple of really, just to make the situation a little bit worse, there are a couple of really tight requirements on 5G that will increase the pressure on the backhaul. So first of all, the user experience. There are new services like 3D gaming that really require really low millisecond level of latency in order for the services to work. There also users are constantly demanding new faster services, ultra high definition video, for example. So bandwidth of 10 gigabits and more is going to be needed. There are also new services. IoT is going to be a major service in 5G. We're talking about connecting millions and millions and potentially billions of devices to the network. So the network has to be able to connect all of these devices, and the service has to be reliable. So if you talk about innovations like connected cars or robots or drones, they really need reliable network connections in order to operate reliably. A third driver is the infrastructure evolution. So there will be new services like, for example, network slicing, which is used in enterprise services like SD-WAN, which is going to set another requirement for managing and monitoring of the backhaul. So I'm working for a company called Expo. I'm not sure if you've heard about it, but we've been in the industry for 30 years. We position ourselves as the network test, monitoring and analytics expert. The background of the company is really in fiber networks, understanding and testing fiber networks, but we've been building our service assurance on top of that. So we are still number one in optical network testing, but we are also one of the leaders in active testing, having one of the largest systems, or actually the largest active test system in the network. We have about 90 customers globally on the service assurance side, and another 200 on the fiber optical side. So we are today about 1,500 people globally, headquarters in Quebec still, and we have about company revenues are around 250 million per year. So we know what we're talking about. We've been in this industry for a while, and we've been developing the solutions and the expertise really to understand the entire network infrastructure and stack. So today we are offering solutions mainly on 4 fields of play. One of them is mobile core, the second one is mobile access, third one is broadband, and the fourth one is enterprise services. So we basically built a solution stack that is illustrated on the right-hand side of the picture. So we have as a basis of the offering, we have data sources. So we have field test data coming from the portables, coming from the instruments that are being used by the field technicians. We have service and network monitoring solutions, so active probes, passive probes, third-party solutions. We have also a fiber network management and monitoring system. And we also use third-party data. So we are collecting, for example, information directly from network elements, OSS and BSS systems, third-party inventory and topology systems to our solution. Now, we have an aggregation layer. So the idea is that we are collecting lots of real-time data from the network from various sources. We are combining and correlating it together, and then we are using different technologies to come up with the different kind of findings. So, for example, today I'm going to talk more about machine learning and prediction capabilities, but we also have more heuristic, rule-based, real-time analytics capabilities. We're talking about enriching the data, doing geolocation, modeling the network topology and structure. All of this information is being fed then through different kind of applications to our key user groups. So we have, in my area of business in service assurance, we're usually working with network operations and service operations people and network engineering, but we also have solutions to serve customer care, marketing, field operations. And they usually use our application then through the analytics applications or more specific applications for individual domains. So to give you a little bit of context, today I'm going to talk about more a solution called X4Works. This is our solution for active testing. Are you familiar with the concept of active testing? You are? That's good. So we have basically several different active test scenarios, and trying to cover them in few minutes. If you are familiar with this, we don't need to go into details of everything. But the high level of idea is that we are using either virtualized probes or test agents on different parts of the network and simulating then transactions between the different agents or verifiers in the network. So we can either run the tests from the verifier or from the agent against another verifier agent, or we can run it against different network elements. So we just officially announced the partnership with Contron last week. So we have been working together in onboarding our virtual verifiers on top of SYMKLOUD. And for example, that type of deployment would be typical in a core network in a data center, which is the scenario number 3 here. We would be placing our verifiers on top of the whatever hardware platforms are available on that location, and then using that to test the connections to different parts of the network, right? So we could be testing against the individual cell sites, which means that we are testing the backhaul part of the network. We could be testing all the way to customer premises. We have a piece of software called virtual agents that run on for example, on the CPE, the customer premise equipment. Or we could be testing against the another verifier in the transport network to test basically the transport part of the network, right? And all of this data is being collected into element management system called Works, or correlation system called Works, and then from that it's being fed into an analytics platform called Extract, which is really designed to be the real-time monitoring and analytics component on top of Works. And the verifiers are being used today in for two different use cases. We have the first of all, the service validation. So whenever there's a new service created or new service being deployed, the verifiers can be used to, or the probes can be used to test that the service is up and running. And then after the validation, it can be also used for 24/7 monitoring. So basically assuring the quality and performance of the network and the services. And there's a wide variety of services that can be executed. It can be a simple connectivity test, or it can be more advanced. It can be, for example, voice over LTE call, in which case we implement the voice over LTE call and it's being answered by another probe on the other end, and we measure, for example, the quality of the voice between the two verifiers. So that's how it's being done today. And it's being used by network operations, network monitoring people to understand really the performance of the network. But it's pretty obvious that it's based on real-time data. So the service either works or it doesn't, and you will get the real-time visibility into that. Now, one of the challenges in moving into new network technologies is that the network infrastructure is getting more and more complex all the time, and there is more data and more data sources to be understood. And real-time is good, but it's not necessarily always enough, right? So we can use new technologies and new innovations to actually move this paradigm from being real-time monitoring into more predictive direction. So we have been developing a concept for predictive assurance, especially for the backhaul and transport use cases. So again, we're using the probing, the virtual verifier, the active test infrastructure for collecting the data. So we have here segments of network. We have the end user, we have access network, backhaul, and core network, and we are using the verifiers and probes to run active tests across the for the different services across the network. Now, again, we are using Works to collect the data. The new part here is that we are feeding the Works data to a cloud instance. This is a machine learning based instance running in off the premises, basically consuming all the data, active test data coming from the network, using that information to learn the behavior of the network, and based on that information actually predict the next steps that are going to happen in the network. Now, in physical network, you can't actually go ahead and fix those things automatically. So many of the findings have to be fed into network operations and service operations, where you have a human being accessing that data and reacting on that. But of course, when we are moving more towards NFV and orchestrated networks, actually some of the actions can be performed automatically. So the predictive assurance model, we tried different options, and our experience is that the unsupervised learning methodology is the most suitable for this, because it's proven to be efficient, for example, for clustering or finding anomalies within the data. So we basically we've been developing the model for 4 different purposes. So first of all, it is important for the module to be able to identify an outage. Obviously, outage is the most severe form of service degradation in the network. So the module has to be capable of understanding when that outage happens. But it also needs to understand what happens before the outage. So finding the causal degradations of service that eventually lead to an outage. So of course, things like earthquakes or power outages cannot be predicted. They are very sudden of nature and they just happen, and you can't really predict that. But other than that, there are, most of the cases, there are pre-warning signs. And those are the signs we want to collect and automatically process and learn how to basically predict an outage based on that. Now, when outage happens, sometimes the network and the systems are clever enough to recover from the outage situation. Like IP network is very resilient. And typically, for example, the connection to cell sites is doubled. So if a primary fault or primary path fails, usually the packets are routed via the secondary connection and the system is able to recover by itself. And these kind of situations, human being is not usually fast enough to react on those. System is able to recover automatically. And in those kind of outages, there is usually no need to notify the network operations people, because the problem is already resolved. And that's what we mean by classifying the outage. And eventually the fourth target for such a module is then execute the right corrective actions. And again, like mentioned earlier, this is probably more for the NFV and more for the virtualized environments. So what we actually do is that we feed, to put it a little bit more into a concrete form, what we do is that we feed the active test KPIs to the module. So the KPIs can be very pragmatic. They can be frame loss, so they can be frame delay and variation. They can be one delay, or they can be network utilization data. And as we keep feeding this information to the machine learning or the predictive module, it can actually use this information to start predicting configuration issues. You can actually see equipment failure, right? Like, for example, there's a scenario when a single cell site is producing constantly higher frame loss than the neighboring cell sites that are being served by the same connection, same transport or same backhaul connection. And then the most typical reason for this is a hardware failure in that particular location. Bandwidth exhaustion, so you can gradually see the bandwidth being filled and eventually leading to an outage. Or you can actually see a service congestion, which is more like a spike in the service consumption in a certain locations. And things like that, the machine learning algorithm is able to discover itself. Usually it would require hundreds and hundreds of man-working hours to on consulting, basically trying to understand the patterns and the structures and come up with the findings like this. So the infrastructure that we have implemented here is quite simple. So in the live network, we still use the same components that we used before. So we're using Works and Extract for the data collection and analytics. There is a cloud instance to which we are feeding the data via the API. And there's a big data storage. There's the training module, which will basically constantly read the recent data that we've read in. And then there's the prediction module, which is the one creating the actual model for the prediction. And then once the algorithm has been, well, it's not actually trained, but once the algorithm is consuming the data, then it can actually start finding the causal factors for the degradation, and that's the inference it feeds back to the extract monitoring system, which is again the one notifying the end users about potential degradation. Okay. So that's on a high level the concept that we are presenting here in Mobile World Congress. We're actually running a demo on our booth. You're welcome to come and see more detailed presentation of what I showed to you today. In that demo scenario, we are using virtual verifiers located in Europe. We're feeding the data into the cloud instance, running the machine learning, and then we are using the monitoring and analytics solution really to display the findings. So we have basically on a high level, we were able to show geomapping of the events that we are collecting in the network and the alarms that it produces. We are able to show the test topology and the setup that how the entire system is basically constructed, and then we are also showing the segmentation. So basically the mechanism how you can break down the active test data collected from the network to analyze the network in smaller pieces and use that information for troubleshooting purposes. So that's on a high level. Thank you for your time. Any questions? Actually, the probe itself is just the component executing the test, right? So the real intelligence, in a sense, is in the test configuration. So the probe is just a mechanism to execute whatever is defined in the test itself, right? Now, in the NFV environment, we are working together with the orchestrator providers and with system integrators, so that you can actually start creating new tests based on, for example, the service templates that are being used in the orchestrator when new services are being deployed. So there is a way of using then the defined APIs, actually create new test configurations and feed that to test management system, which in turn deploys the new tests to the verifiers in the network. So we don't support directly creation of probes, but we do support creation of new test configurations via the APIs. Okay. Very good. Thank you for your time, and hope to see you for demonstrations later on.